Here is an overview of the proposed changes to the dimension input user interface. So if I start by, let's say, the simple example, a pulley, right? So I want to make a radius for the overall pulley. I'm going to say it has 10 teeth, 5 millimeter pitch, and diameter, so divided by pi. Okay, so that's our outer diameter. Now let's say I want to adjust for the thickness of the belt, how that will affect the radius of the part. So I can say radius, or belt radius, is equal to 0.572 millimeters. And then we say that's 90 degrees. Okay. And let's just make a circle for that one. So that's kind of like the true outer radius. Now let's say we want to draw the tooth. So the depth of the tooth in this case is 2.16 millimeters. What am I doing? Wrong one. Is equal to 2.16 millimeters. And let's say we want a circle for the tooth, and the circle radius is 1.56. So that's times 2. So that's a different Freecad version. 1.56. So let's just call this diameter 1 for our tooth diameter 1 is equal to 2, or 1.56 times 2 millimeters. Okay. And so we want those to be coincident. Now let's say the little fillet radius here is 0.5. So we'll say diameter 2 is equal to 1, or tooth diameter 2 is 1 millimeter. And if I reference that, I can say HTD-2, and it automatically grabs that dimension from the spreadsheet. So I want these to be tangent to the inner diameter on the other side. My gosh. Okay, tangent. Okay, so now we're going to have lines connecting those. So we want those lines to be tangent to our two circles. Tangent. 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 Okay, so that's fine. And we want those to be symmetric, so I'm just going to have two horizontal constraints. And let's say we want the angle to be not that, we want this to be 14 degrees. Which I guess I could have parameterized that, but I don't think that changes much between the different pulleys. So that's our sketch. Now we can turn everything into whatever this is called, construction lines. Okay. Okay, so now we want to make the actual final geometry. So I'm going to do arcs for these. Is that going to let me do the thing? Or will this break everything? Nope. Okay, so we want that maybe to disappear. Okay. Sequence that. This. Is that going to break? Yeah. Okay, well, it accepted that. Cool. Now we do more arcs to finish up that. Okay, and now I'm just going to add a little offset so that we can make a nice little tooth thing that sticks out. So now we're going to close the shape and then we can cut this out of the pulley. Cool. Okay, so that is our pulley tooth cut out. So now we're going to make the actual pulley body, which maybe I should have done that first. But so let's say that the inner diameter, we just want to have that. So, or this is the outer diameter of the pulley, but OD is equal to diameter minus belt radius times 2. Let's see what happened there. Diameter, belt radius. Oh, did we not save diameter? That's a little bit weird. What is that? Oh, I just hard coded that. Okay. I'm just gonna do that. Okay. So now that says diameter. Okay, cool. That should fix things. So yeah, now we can say that's diameter minus tooth or belt times 2. Great, so that's our outer diameter. Wait, actually, yeah, right, I was going to save that as OD. Okay, so that's our outer diameter. And then we have the, let's say the inner diameter, we want it to be outer diameter is equal to OD minus 2 times tooth depth minus 2 times 2.5 millimeters. Yeah, there's a bug in the expression parsing, so you can't have millimeters at the very end, I guess. So ID is equal to OD, or maybe it saved it. I don't know. No. Oh. Okay. 2 millimeters times 2.5. Still doesn't like that. OD, ID, tooth depth. Oh, I didn't spell that. Dirt. Okay. Okay, great. So You have to type things correctly. Now we can say that as ID. Okay. So we have this, and now we can finish that. Okay, and now if you go back to part design, extrude, let's say thickness is equal to 10 or 15 millimeters. Cool. So that's that, and then now we want to cut out the other sketch that we have. So I'm just going to move this down for simplicity, and then we're going to do this. Okay, great. So now we have this tooth cut out. So let's say we want to radial tile that feature or whatever. Polar pattern, we're going to say tooth count equals 10. And we're going to say okay. Great, so now we have that. And if we want to change the number of teeth, we can go here. We have to change the diameter equation. Instead of hard coding that, we can say tooth count. And instead of 10, we can say 32. And we can go back to the part, and now we have a GT5 timing belt with 32 teeth instead of, 10. Or let's say we want to go to 128. We can let that figure it out and go back, and now we have a timing belt with 128 teeth. So as you can see, the input is a little bit nicer. It's much more similar to other tools like SolidWorks and Fusion 360.